In this section, we're going to be looking at segment length and midpoint. We're going to be finding different pieces of different segments and then being able to calculate how long things are based on whether we have a midpoint or not. So let's get started. The first thing I want to talk about is the notation for a segment. So if I have a segment AB, I could name that segment by saying, okay, that's segment AB with the bar over the top. That means segment AB. But if I wanted to consider the distance or the length of AB, I could just write regular AB. So without the bar, it means the length or the magnitude. So that's just a bit of the notation for that, and then we can move on. So if I have this example, and I have a number line here, and it says find EC, I think that should be pretty easy. All you're going to do is subtract the larger number minus the smaller number. So the point from the far right, so I'm going to be subtracting that minus that. So just to refresh our memories, we would do 1, because 1 is farther to the right of this. That means it's bigger. So we'll do 1 minus -4, include the negative. You can write it like that, or you can put parentheses around it. Whenever you have a minus a negative, that's the same thing as adding. If you subtract a negative, it's the same thing as adding. Hopefully we remember that. And so that's 5. So EC equals 5. Note it's not this, because that's referring to the name. Right now we're referring to the length of EC, so we don't put the bar in the top. So that would be that. For the second part, let's do find FC. No, FE. And then another one, find DE. So FE, I would say what you can do is just subtract, so we'll do it again. -1 FE minus -4. When you have a minus and negative, that's the same thing as adding. And then here, what I do, since I have one positive and one negative, I just do the same. It's the same thing as 4 minus 1. And I can think about that better. But I have 4 positives and 1 negative, so I get 3. So FE equals 3. And then DE, well, I'll just do D, which is at 3.5, minus E -4 again. Subtracting a negative is the same thing as adding. So I get 7.5. DE equals 7.5. Hopefully that's not too difficult. We're now going to look at a definition. Let's see. So here the definition is congruent segments. Congruent segments are segments that have the same length. So I could represent that by saying, okay, if they are the same length, one thing I could do is I could put a little tick mark. That little tick mark means that those segments have the same length, and I can say RS with the bar over it, the name, is congruent, so that's an equal sign with a little squiggly over it. So congruent to PQ, which means, that the length of RS is equal to the length of PQ. Notice the difference between those two notations. This means congruent, and if two segments are congruent, their lengths are the same. So there we go. We're going to look at another definition. This is the definition of midpoint. So midpoint, hopefully it's obvious, but we'll see. Now I think this would make more sense once you draw it, so I'm going to draw it as well. But it says B is the midpoint midpoint is what we're defining. B is the midpoint of segment AC if AB is congruent to BC. So what the heck am I talking about? Well, B is some midpoint of segment AC. So I'm going to draw segment AC. Label that A, label that C, and then B is the midpoint of AC if AB, this, is congruent to that. Note B has to be in between A and C. Hopefully that's obvious, but that's just saying that they all have to be collinear points, all three of those. So that we have midpoint, and I think we can do another example. So here we have B being the midpoint of AC, just like we had before. AB is supposed to equal 5x, BC is supposed to equal 3x plus 4, and we're supposed to find AB, BC, and AC, all those lengths. So, the first step is to draw this, and I know that B is the midpoint, so that means this is congruent to that. Another way of saying this is B bisects A and C, which just means it cuts it in half. Bisect means to cut in half. So, if AB is equal to 5x, that means this part is equal to 5x from here to there. And then BC, well that's from here to here, that equals 3x plus 4. But since B is the midpoint, those have to be congruent, so I can set them equal to each other because those are distances. And I know they're distances because it doesn't have the bar over the top when it says that. So 5x equals 3x plus 4. And then I'm going to solve the equation. I'm going to get my letters to the left side and my numbers to the right side. So minus 3x to move it over. Minus 3x. It goes away. 5 minus 3 is 2x. So 2x equals 4. And then I will divide by 2 to get the x all by itself. X equals 2. But remember, it says find AB. We just found x, so we're not done yet. So that's not our answer. Well, AB, remember AB is equal to 5x, so I'm going to plug it back in. AB equals 5 times x. So then AB equals 10. BC, what was that? BC equals 3x plus 4. So BC equals 3. Instead of writing x, I'm going to write 2 because that's what x is. 3x and then plus 4. So BC equals 6 plus 4. BC equals 10. Of course, it should equal 10 because we said those were the same. I actually didn't even need to solve that last one. But then it says find AC. Well, AC is just both of them added together. That's actually using the segment addition postulate. But B plus BC, AB plus BC has to equal AC. So then AC equals 20.